Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Well, that was super weird. I was literally in the middle of streaming and my computer just went, bloop, we're restarting due to an unknown problem. Gotta love technology. So last week it was a thunderstorm. This week, and we ended up losing internet and power. So everything went out for a few hours. And today it was the computer just saying, we're going to do a random update. But it still stayed live. So that was weird. I apologize for that. I don't know what happened. But here we are. So welcome to Math Night. I don't know how much of Dr. A's video you saw, but we are the Learning Liaisons, and we are so happy that you are with us tonight. I am Amy Sink. I am one of your math specialists, and I will be going over a few problems tonight. Usually I try to go over about 10. For us to review different math concepts that you might see on your math exam. Hi, Denise. It's good to see you. So before we get started, I always like to do a get to know you. It just helps me get to know who's in the room and also helps me guide our conversations for the night. So, hey, Chris. Hey, Marcus, maybe? I don't know your YouTube name. I don't know what your name is. So hello, welcome. It has been a crazy day. I don't know about you. Back to school is always crazy. So it's been a crazy day. But it is good to see you all. It is good to be back. It's good to have power. It's good to, it's great that my computer didn't just die on me tonight. And I am just happy to be with you in solving math problems, which truly is my passion. So let's go ahead and get started. Hey, Jasmine, here's what I want you to do. In the comment box, I want you to comment where you're from, what test you're prepping for, because that helps me guide our conversations tonight. So where are you from? What test are you prepping for? And if you could have any job in the world, what would it be? What is your absolute dream job? If you could do any job in the world, what would it be? Honestly, mine would be a dance choreographer for a competitive high school dance team, specifically contemporary, while also being an assistant principal. I know that sounds absolutely wild, but that would be my dream job because it blends two of my absolute loves together. So, you had the same problem with the thunderstorm. It was so annoying. And usually we don't lose power during thunderstorms, so that was weird. So where are you from? What test are you prepping for? And what is your absolute dream job? Like if you could do anything, like dream big. Don't just go normal. All right, let's go ahead and get started with problem number 1. A teacher has a bucket of crayons for students to share. In the bucket are 12 purple crayons, 16 gray crayons, 10 green crayons, and 12 yellow crayons. What is the probability that a student pulls a green crayon from the bucket? Hey, Marco. Hey, I was close. Even though it wasn't Marcus, it was Marco. You're from Florida. 6 through 12 math, awesome. And soccer coach. I love that. Denise, FTCE math 6 through 12, and you're Turkish. Awesome. Chris, 4 through 8 math. Your dream job is a chef. That is so cool. I am terrible at cooking. We have a lot of 4 through 8 and 6 through 12 people here tonight. I love it. And knowing that, I will definitely gear some of my problems next week specifically for you 4 through 8 and 6 through 12 people. So let me know exactly what are you struggling with so that I can kind of tailor our presentation next week since there are so many of you in here tonight. All right, probability. I feel like every time I ask, what do you want me to go over? I get probability at least once. So when we talk about probability, simple probability, we are looking at our desire over our total outcome. So in this problem, what is our desire? Our desire, or what the probability that we are looking for, is the probability that a student pulls a green crayon from the bucket. So we're looking for green crayons as our desire. So if we have desire over total possible, the desire is a green crayon, which is 10. The total possible outcome is going to be all of the crayons in the bucket. So we have purple, we have gray, we have green, and we have yellow. Probably one of the most common mistakes people make is they put the 10 on top, and then when they do the total outcome, they do 12 plus 16 plus 12. And they don't include the green because they already put the green up here. But how many crayons are in the bucket total? Those 10 green count. So I have to make sure I include those. So my probability is going to be, I'm going to use my calculator for this one. 12 plus 16 plus 12 plus 10 out of 50. And now I'm going to go ahead and simplify that. So my middle school and high school people, simplifying fractions should be very common knowledge for you. You should be able to do that lickety split. But my elementary people, it might not be as straightforward for you. So when I'm simplifying a fraction, I'm trying to find what I can divide the top and the bottom by at the same time. I'm going to divide the top by 10 and the bottom by 10 because they both end in the number 0 or the digit 0. 10 divided by 10 is 1. 50 divided by 10 is 5. So the probability that a green marker is pulled out of the bucket is 1/5. Oh, Jasmine, that's a good one. Travel the country and get paid all while having fun. I love it. All right, now we are going to take this exact problem and redo it, only with a different question. I love doing that because I love to show you that the same problem, there could be multiple questions that stem from it. So this teacher has, I'm sorry. This teacher has the same bucket of crayons with 12 purple, 16 gray, 10 green, and 12 yellow. So same bucket of crayons. What is the probability that the student pulls a green crayon from the bucket, leaves it on her desk, and then pulls out a yellow crayon out of the bucket? Remember, our probability is our desire over our total, but that's simple probability. In this situation, we have probability of the first situation and we have probability of the second situation. So because of that, we have two different probabilities we are looking at. We have the first situation and we have the second. And when we have a situation like this, we multiply them together to get our answer. So, desire over total. We have 10 green out of 50. We know that because we already solved that. So the student is going to pull a green crayon from the bucket and leave it on her desk. Then pulls out a yellow crayon. Now, you could simplify this or you could leave it as 10 over 50. It's up to you. I'm going to simplify it because then when I multiply, it's going to make my life a little bit easier. But if you forget to simplify or you're not comfortable simplifying at that point, just leave it and go ahead and simplify it later. That's not a big deal. But she's pulling a yellow crayon out of the bucket next. How many yellow crayons are there? 12. Out of how many crayons are in the bucket? You're tempted to say 50, aren't you? Except she pulled the green crayon from her bucket and left it on her desk, which means we are not replacing the crayon. This is probability with non-replacement. So there are now only 49 crayons in the bucket, not 50. So now we can multiply through. Now again, you could do 10 times 12 and 50 times 49, or you could do 1 times 12 and 5 times 49. I'm going to do the 1 times 12 just because it makes it a little bit simpler. So 1 times 12 is 12. 5 times 49. I am going to do this the long way or using the standard algorithm. I could use a calculator, but my elementary people don't get a calculator. So 9 times 5 is 45. 5 times 4 is 20. 20 plus 4 is 24. And 12 out of 245 cannot be simplified, so our answer is B. Now, what if they asked this? I'm going to throw us another one. What if they asked this? I'm going to erase some of this. What if they said, pulled out a green crayon from the bucket, leaves it on her desk, and pulls another green crayon out of the bucket? It would be out of 49 because we took the crayon and we didn't replace it. But what I need you to realize here is it would not be 10 anymore because we're pulling the same color out in our second probability. So that would end up being 9. That you have to pay attention to these little nuances because these nuances are what are going to trick you and make you get the wrong answer, even if you know the process and you know what you're doing. So paying attention to those nuances is really critical. All right, I'm not going to solve that because that was just an example, right? All right, let's move on to the next problem. This is a middle school, high school problem for sure. Probably closer to high school, closer to my 6 through 12 people, but definitely a problem we need to be aware of. If f of x equals 4x squared minus 3x plus 2, and g of x equals 5x minus 8, then what is the value of f of g of 1? I want to break this down because this notation throws people off every single time. So if I said, here's f of x equals 4x squared minus 3x plus 2, and I said, what is the value of the function when x equals 1? What would you do? You got it. You would take the number 1 and you would plug it in for x. So then I'm going to take it a step further. What would you do if I gave you this? Using f of x. This means the same thing as this. What is the value of the function when f of 1 or at x equals 1 for the function? All this is saying is what is the value of the function at x equals 1? So because of that, I'm going to take x or 1 and plug it in every single place I see x. I'm going to plug in 1 here, and that's it. So this is just a more complex version of that. What does order of operations tell us to do? It tells us to solve inside the parentheses first. So I'm going to do g of 1, and then I'm going to plug that value in. I'm going to substitute it and then continue to solve. So g of 1, 5 times 1 minus 8. What is 5 times 1? 5 minus 8 equals -3. Now, I'm literally going to, because g of 1 equals the same thing, -3, I'm going to replace this entire piece with -3. So now I'm just looking for f of -3. For x squared minus 3x plus 2. 4 times -3 squared minus 3 times -3 plus 2. Now, even though this is a high school problem, elementary people, you have to know how to do order of operations. So this right here is right up your alley. I'm going to solve my exponents first. So 4 times, what is negative 3 times negative 3? Positive 9, because a negative and a negative is a positive. Negative 3 times negative 3. Positive 9. This becomes a plus 9. Now, if you read this as minus 3 times negative 3, 3 times negative 3 is negative 9. So I would be doing minus negative 9, which just turns into a positive 9 anyways. So all of that becomes a positive 9 plus 2. 4 times 9 is 36. Plus 9 plus 2 is going to be positive 47. So D is the correct answer. Denise, excellent job. You solved that really quickly. I'm really impressed. Good job. All right, let's move on to the next problem. Middle school and high school people, this one is for you. A ball is thrown into the air at 45 feet per second from the top of a building. The quadratic equation H equals negative 16t squared plus 45t plus 85 represents the height in feet of the ball over time in seconds. If the ball is untouched after being thrown, how long will it take for the ball to hit the ground? Here's what I want you to realize. This is a lot of words. And for some people, this is very confusing. For some of us, we can look at this problem and go, lickety split, all done. But for some people, they can't, and it's very overwhelming. So here's what I want you to realize. If this problem is overwhelming for you, all I see is blobbity, 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 blah, blobbity, blobbity, blah. Here is the equation I am working with. They gave it to you. They told you what the equation is. You don't have to build the equation by yourself. That is huge. Then it tells us that equation represents, gives us the height in feet, don't care about that, of the ball. How high is the ball over time? After 1 second, how high is the ball? After 2 seconds, how high is the ball? After 3 seconds, how high is the ball? After 4 seconds, how high is the ball? After 5 seconds, okay, I got a little carried away with my choreography. How high is the ball after a certain number of seconds? So if you can't interpret this because this is just too much, break it down like that. Now, for those of us who love these problems and can do these problems in our sleep, we read this and we understand 45 feet per second, top of a building, the quadratic equation creates a parabola. It's upside. Like, we can do all of that. And I am going to go through that very quickly for the people who don't get it. But if you can't interpret this problem at all, the least you can do is that. If the ball is untouched after being thrown, how long will it take for the ball to hit the ground? So let's draw a picture of what this looks like. When I draw a graph like this, I typically make my first quadrant larger than the rest. Why? Because the first quadrant is going to have a positive x, which is my time, and a positive y, which is my height. I'm not going to end up with negative seconds in time, and I'm not going to end up with like negative height. So what that means is that this problem has constraints. The constraints are that It's not going to go into negative time, and it's not going to like bury itself into the depths of the earth, right? So I know this is an upside down parabola because it has a negative a value. So we're looking at something like this, where I throw the ball from the top of the building, it hits its maximum right here, and then it starts to fall, and then it does what? Hits the ground. Because this value right here is when the height is 0. So how am I going to solve this? Well, when I look at my answer choices, I pretty quickly see that I can't factor this. So I'm going to use the quadratic formula, which is just one of our many menu options to find the x-intercepts or the zeros of a quadratic function. So the quadratic equation negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where a is the value in front of the x squared, b is the value in front of the x, and c is the value that's all by itself. Here's what I want you to understand. Sometimes they will scramble those values up to confuse you. So they might sometimes write the equation like this. Hoping that you use this as A and this as B and this as C. But we know from standard form that the A is always attached to the squared exponent or the squared variable. The B is always attached to the variable with the 1 as an exponent, and the C is always our constant. So don't get confused by their little tricks. Quadratic equation, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Woo! That's a lot. So let's keep going. Let's simplify this down here. Negative 45 plus or minus the square root of, handy dandy calculator in this situation, 2025. 4 times 16 times 85. 5,440. Are we adding those values or are we subtracting those values? Well, it is a -4, but it's also a -16, and a negative times a negative is a positive, and we already talked about that. So this is going to become a plus all over -32. I'm going to add those values together. So I have -45 plus or minus the square root of 7,465, all divided by -32. Now, the plus or minus literally means I'm going to do a version with a plus and I'm going to do a version with a minus. So I'm going to make this graph a little smaller so that we can finish this problem. I have -45 plus the square root of 7,465 divided by -32. And I have -45 minus the square root of 7,465 divided by -32. What is the square root of 7,465? 86.40. And granted, when you look at this calculator, that number goes on forever. I'm going to just use 86.4. So I have negative 45 plus 86.4 divided by negative 32. And I have negative 45 minus 86.4 divided by negative 32. So 86.4 minus 45 is 41.4 divided by negative 32. And already I realized that that is going to become a negative number because a positive divided by a negative is a negative. So I'm not going to choose that answer because it's not going to take negative time for the ball to hit the ground. So now I'm going to go to the next one. 45, negative 45 minus 86.4 is negative 131.4 all divided by negative 32. I'm going to continue that up here. So negative 131.4 divided by negative 32. A negative divided by a negative makes a positive, and that's going to give me positive 4.106, which rounds off to 4.12, which is why C is the answer. Any questions about that? All right, we're about halfway through our problems for tonight. If there is anything you want to see from me in the upcoming weeks, please leave it in the comment box. I absolutely love creating a next week section. And so when you tell me what you want to see me go over, I add it to our next week section. So keep that in mind as we're solving problems. Let's go ahead and keep going into our next problem. A ball is still thrown in the air. So when you see that I have like a 4A, that typically means that the next problem we do is going to be exactly the same with a different question. So we still have a ball being thrown into the air, going up and then down. So I'm going to copy our little picture right here. And paste it so that we have an image of what we're working with. So the ball, I'm way up at the top of a building and I throw a ball up and it comes all the way down. This quadratic equation models the height and feet of the ball over time in t seconds. What does the value 85 represent in the equation provided? What does this value right here represent? A, the amount of time it takes for the ball to reach the maximum height. B, the maximum height the ball reaches. C, the height of the ball prior to being thrown at time equals 0. Or D, the distance the ball travels after being thrown at 45 feet per second. Denise, absolutely ask me whatever you want. You don't even have to ask me to ask a question. Just go for it and I will answer it when I can. So, what does 85 represent? Again, for some of us, we can look at this immediately and know the answer. And for others of us, we can't. So I'm thinking to myself, if I have this equation, and I'm trying to figure out what is 85 mean? Well, 85 is if none of this exists. How do I get all of that to disappear? By making t 0. If t is 0, then this is my y-intercept. So if that is my y-intercept, then that means that is where I'm standing to throw the ball for it to come all the way back down. So that is not the amount of time, because think about it. If 85 is all by itself and all of this disappears, then it's h equals 85, which means its height equals 85. So it can't be a time, it has to be a height. It's not how far the ball travels, so it has to be B or C, which is maximum height or the height of the ball prior to. But 85 is going to be my y-intercept, which is where the ball is prior to me throwing. So I climb up to the top of the building, I'm holding my ball, and then I throw it. 85 is how tall that building is, which is C. All right, Denise, I saw that you answered your question yourself. I'm glad. Let me know if y'all have any questions as we are solving these problems. All right, problem number 5. The triangle shown below is a right triangle. Find cosine of theta. Find cosine of theta. So the fact that they told us that it's a right triangle is golden, because if they did not tell us that the triangle is a right triangle and they did not give us this 90-degree angle symbol, we cannot assume it's a 90-degree angle. And so often I coach and tutor so many people that make that mistake. They think, oh, it looks like a right triangle, so it must be a right triangle. They see a set of lines that look something like this, and they say, oh, those lines look parallel, so they must be parallel. Or they see a set of lines that look like this, and they say, what is the relationship between these lines? But they didn't give us a slope. They didn't tell us that they intersected a 90-degree angle. We cannot say that they are perpendicular lines unless we know they have negative reciprocal slopes, or we can prove it by looking at the slopes or by using points, but we cannot assume anything in geometry. We have to be able to prove it. Hence, proofs in geometry if you're a high school person. So that said, and that's a soapbox that I get on a lot of times because it gets a lot of people the wrong answer, unfortunately. And so I don't want you to miss a problem because you incorrectly assume something. So this is a right triangle. Find cosine of theta. There's a little mnemonic that I use to remember sine, cosine, and tangent relationships, and it is SOHCAHTOA. And it's just a fun little catchy thing, SOHCAHTOA. I don't know why, but it's just rolls right off the tongue. And SOHCAHTOA means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And this is all sine of theta, cosine of theta, and tangent of theta. So when I'm looking at theta, opposite is just what it sounds like. Opposite of the angle. Adjacent is just what it sounds like. It's sitting next to or adjacent to the angle. So of this theta, this would be opposite. This would be adjacent. And this is going to be hypotenuse. Because hypotenuse is always going to be across from your 90-degree angle. No matter how the triangle is laid out, it is always going to be across from the 90-degree angle. So that said, when I look for cosine of theta, then I'm looking for adjacent over hypotenuse. I'm looking for adjacent over hypotenuse. And I'm telling y'all, when I solve this problem, I literally will write SOHCAHTOA on my paper or on my board or whatever. So, SOHCAHTOA, adjacent over hypotenuse. So adjacent is going to be x, and hypotenuse is going to be 15. Problem. I don't know what x is. And when I look at my answer choices, unfortunately, I have 3 answers over 15. So at least I can cross off D. At least I have a 75% chance of getting it right. Now, how do I find x? Everybody needs to know this. Even if you don't need to know how to know cosine, you need to know Pythagorean theorem. A squared plus B squared equals C squared. That is for right triangles only. Right triangles only. So you're asking, what is A, what is B, what is C? C is always your hypotenuse. A and B are always your legs. So 12 squared plus x squared equals 15 squared. 12 squared is 144 plus x squared equals 15 squared is 225. Subtract 144 from both sides. If I am going too fast, you need to let me know. X squared equals 81. Square root both sides. X equals 9. So this side is 9. So B is my answer. Any questions about that? All right, we're going to keep moving on. Ooh, this is one of my favorite problems from tonight. All right. A second grade group of 100 students surveyed each other to find out what each student's favorite ice cream flavor was. So there are 100 students surveyed, and they surveyed to figure out what is their favorite ice cream flavor. Chocolate, vanilla, strawberry. Denise, I saw that you asked, is this formula correct? I don't know what formula you're talking about. A squared plus B squared equals C squared is absolutely the right formula for Pythagorean theorem. I'm just not sure what you're referencing, so just clarify for me. The diagram to the right shows the students' favorite ice cream flavors. Half of the students not represented on the Venn diagram like chocolate only, and the other half like vanilla and strawberry. What fraction of all the students selected like more than one type of food or ice cream? So this is an interesting question because they said there's 100 students surveyed, but then they said that there's students not represented in this diagram, and we need to make sure we're representing all students, right? The number one thing people are going to do on this problem is they're just going to jump right to what fraction of all the students selected more than one type of food. And they know that there's 100 students, so they're going to go over 100, and they're going to dive in and see how many students chose more than one type of food. But we have to make sure we represent the kids that are not represented. So I have to add up all these numbers to figure out how many kids are not represented, add them back into this, and then solve it. So I'm going to add in my handy dandy calculator 14 plus 7 plus 24 plus 12 plus 15 plus 6 plus 14. There are only 92 students represented here. I need to make sure there's 100 students. How many am I missing? I'm missing 8 students. So if I'm missing 8 students and half of those students like chocolate only, then I need to add 4 to the chocolate only because half of 8 is 4. It's a lot of math in this problem. And then the other half, like vanilla and strawberry. Well, where am I going to add that? It's not going to be here and here because this is vanilla only and this is strawberry only. I need to add it into the vanilla and strawberry together. So, hey Monique, how are you? It's good to see you. Vanilla is the yellow circle. So I'm going to color the vanilla yellow. Strawberry is going to be the pink. And chocolate is going to be the brown. All of the kids in the brown circle like chocolate, but only these kids like chocolate only. These kids like chocolate and vanilla because they're in both the chocolate circle and the vanilla circle. These kids like strawberry and vanilla. So that's where I'm going to add the extra 4 kids. So this actually becomes 18 and this actually becomes 10. So what fraction of all the students selected more than one type of food? We're looking at it out of 100 because we know there were 100 students surveyed. And if they chose more than one, they have to be sharing in a circle space. So it's going to be the 7, the 12, the 15, and the 10, not the 6, because we added 4. So 7 plus 12 plus 15 plus 10. So I'm going to use my handy dandy calculator. And that equals 44 out of 100. Now, I see a huge problem with that. I don't see that answer on my answer sheet. So I need to go through and simplify this, right? So I know that they can both be divided by 2. So I'm going to divide both by 2. 44 divided by 2 is 22. 100 divided by 2 is 50. They both still end in an even number. So I'm going to divide them both by 2 again. 22 divided by 2 is 11. 50 divided by 2 is 25. So my answer is A. Hey, Soy, I saw that you chose a different answer. Please let me know if the explanation makes sense or if you need some more clarification. Monique, you are too sweet. I love you. Thank you so much. I love what I do. Like, this truly brings me joy. So I appreciate your kind words, but I love this. Denise, is this for, so we're going to go back to the other problem because Denise asked if we can use a different formula to solve this problem. Can we use cosine of x equals plus or minus the square root of 1 minus sine of 2x? Okay, is that formula correct? I would have to go look it up, to be quite frank. I don't hold trig formulas in my brain because I just don't find it necessary to personally, unless I'm going to take a test, right? And I haven't taken a test in a very long time. So I just don't hold that information in my brain. All that said, that formula is not necessary to solve this problem because this is a lot faster. With that said, because you have to be able to solve the sine, which I guess you could because sine would be opposite over hypotenuse, so you wouldn't have to use this. So you could do plus or minus the square root of 1 minus the square root of 12 over 15. Oh man, we made it 52 minutes without my computer disconnecting. It was so close. So all that said, Denise, I just don't think that method of solving would be completely accurate for this problem or necessary. So are there multiple ways to solve problems? Yes, but that would be more for like trig identities, not for finding the missing side of a triangle. So you are welcome. That's what I'm here for, right? Answer your questions. I love answering questions. That's what makes this fun, is when you ask questions and I answer, because it makes it a little bit less like talking to a computer screen and a little bit more like a math class. So thank you for asking. All right, we have time for one more problem, and then we are going to look at what you want me to do next week, and then we're going to look at a video from Dr. A. So the above list of numbers, and oh my gosh, this should totally not be on here. That was my note while I was trying to solve it. So if you saw it, good job. The above list of numbers represents the test scores of 11 students in a social sciences class. The 12th student in the class was absent on the day of the quiz. What is the minimum score the 12th student needs to score in order for the average of the scores to be at least an 80? So, in order to find average or mean, we have to add it all up and divide it by the number of data points. So, when I add all of these numbers up, it equals 883. I'm going to prove it to you. I'm going to use my calculator and I'm going to go. And I always do this 2 times. 76 plus 85 plus 64 plus 98 plus 72 plus 72 plus 89 plus 91 plus 68 plus 82 plus 86, 883. I'm not going to do it again because I've already done this like 1,000 times. But if I am solving a problem that has average, where I'm adding a bunch of numbers together, I am absolutely going to add it at least 2 times to make sure I don't make a calculator error. Then I'm going to divide by the number of items that I have. But in this situation, we are looking for a minimum score, the absolute lowest score that student can get and still have an average of 80. So you know what I'm going to do? I'm going to start with the number. In fact, I don't ever start with the number 70. I don't ever start with A, because what if the answer is E? At least if I start with C, I can go up or down from there. So I'm going to add 883 to 78. And that gives me 961. I'm going to divide that by 12 because I have 11 scores here plus the 78. And that gives me 80.08. The average is at least 80 in this situation. So I'm not going to go higher because we're looking for the absolute lowest score this student can score. So I'm going to do the same thing with the 77 plus 883 equals 960 divided by 12, and 960 divided by 12 equals 80 exactly, which means that the 76 is going to give me an average that is just below the necessary threshold. So my answer is going to be B. All right, y'all, we are done for the night. What do you want to see me go over next week? Let me know in the comment box. I'm going to turn it back over to Dr. A, and he has a special code for you, but I am going to stick around for a couple of minutes while he's talking so that I can monitor the comment box. How to find the original function when we have the graph of the derivative. Ooh, that's a good one, Marco. I like it. How to find the original function when given the graph of the derivative. Yes, Chris, I will absolutely include another, I don't know what I just did there. Yeah, whatever. Okay, another Venn diagram example. You got it. I'm going to turn it back over to Dr. A. I will still be here monitoring the comments. I hope y'all have an amazing week this week and a great weekend. I'll see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.